US to Europe. I think it got up to about 2,000 miles per hour. Had some safety issues. Doesn't exist anymore as far as I know. But pretty cool thing in its time. So here it is taking off. It's not yet up over the speed of sound. I believe they waited to get over the ocean before they would do that because it is actually disruptive to people's homes. It's loud. So here, pause for a sec. Here people are out on a boat. They're videoing from a boat. You're about to see it. They'll scroll down. Anyway, they're filming this out over water, and the Concorde notices past them already. So this is like that little simulator we saw before. The source of the sound is well past them. It's not directly overhead anymore. However, the sound waves trail behind. But since it is going faster than the speed of sound, you get that stack up of amplitudes there, the stack up of compressions and rarefactions. And, well, listen to it. Hopefully you hear it. One more time, lady. I think she heard it. Okay. So that essentially covers Doppler effect. So you are now good to go with regard to Doppler effect. And next video, I'll talk to you about the homework. Alright, so here's the homework. I'm going to full screen this. Oh. There we go. So 816, you have to do pages 1 and 2 for homework. Yes, take out your homework and look at this. Yes, you're having a quiz on this later in the week. Yes, you need to know this. Yes, this will be posted on the drive. Alright, so first couple questions up here. Sorry, this is formatted off. There we go. Approach each other. Basically, you just have to realize the source can move toward the observer toward the source, or they both could move. Here, for recede, it could be source away from the observer away from the source, and both away from each other. Anyway, look through these, some of the common issues here. Let's see. So, a firefighter approaching, of course, is going to notice, imagine, the waves get squeezed, a higher frequency. Here, a train is actually leaving the station. You can imagine it's kind of like stretching them out, so the people at the station will actually hear a lower frequency, and what that means is the sound fronts get there less frequently. Number 5, steadily increasing frequency. So increasing or higher frequency is moving toward, but steadily increasing frequency would have to be accelerating toward. Now 6, be careful here. Which type of wave? You're supposed to know, of course, this is sound, so it's longitudinal. But here, 7 is a little tricky, but it is not the Doppler effect. 7 says the microphone is moved to a new fixed location. So the microphone was here. Come on, microphone. And now they're not asking about during the move. They're just saying you move it now to half meter. Leave it there. Now that it's sitting there, what does it notice compared to the old microphone? Well, you're closer to the source, so it's going to be louder, more amplitude. Now they're saying it's moved at a constant speed back. So let's see if we can group this thing. And so at this point, as it's moving back, so there are these waves coming out from the speaker, started out here, as it's moving away from them and they're moving toward, as it moves away, the frequency is going to appear lower. It gets stretched out. Number 9, if you hear a higher frequency, well, you know that the source is coming toward you, and they're asking about what happens to the amplitude. Well, if it's coming toward you, the amplitude should increase. It should get louder. Now, number 10, I told you could skip that one, but you could get it now. I hadn't spoken to you yet about this phrase called the blue end or the blue shift. Now that we know it's blue shift, it's higher frequency, it's moving toward. All right. Question 11. Give some of you a little time to write that. There we go. The waves and an observer are moving relative to each other. You'll have not just a lower, but a steadily decreasing frequency if the source is accelerating away. Now, here's a student accelerating on the way to catch the train. So you're moving toward, but you're speeding up. So, of course, moving toward, the amplitude's going up, and accelerating, the frequency is going up as well. Not just higher, but going up. They're both increasing. Here, the radar gun, I told you could skip it, but you'll understand it now. It has to do with the police and the reflected waves. And of course, that was Doppler effect. 14, the car horn. As the car speeds up, so speeding up going away, of course it's going to get quieter. That's why the amplitude will go down. And the frequency will also continue to decrease, get stretched out. You see these bunched waves, number 15, that tells you Doppler. They're saying position C. Notice the waves appear more stretched out. You're going to get big wavelength, small frequency. For 17 at A, notice they seem squished, so you're going to get a high frequency, small wavelength. It's moving toward A. You have to know that from the bunched waves. Moves in the direction of the bunch, kind of like the duck swimming in the water. Someone at the source, number 19, will not notice any change in frequency. And then rank the speeds. Well, you have to realize speed depends on the medium. Medium hasn't changed, speeds don't change. They're all the same. All right, 21, they're talking about an ambulance driving northbound with a siren 1,000 hertz. So the driver will experience the same frequency as what the siren is making because there's no relative motion. Someone standing north, well, if it's moving north and you're north of it, then it's coming to you. So you could experience a higher frequency. They get squished 1,100. If there were another driver also going northbound at the same velocity, when there's no relative motion, then you'll hear the standard 1,000 hertz unchanged. Finally, a skydiver or free falling overhead. Oh. So it's accelerating toward the ambulance. Well, if it's accelerating toward, then you will be not only an increasing, but a steadily increasing blue shift there frequency. Okay. So those are the homework questions from 8/16 that were due today, and finish 8/16 for tomorrow. Finishing 8/16 is not a particularly tough thing to do. You have this little business down here on the next page. You can do a little measurement on the bottom of page 3. So do it. And then there's a few questions here on the back. Make sure you go through all that stuff. Let me see if I still have this image open. Here it is. For that last question, this image is actually here. Basically, you don't quite understand these lines most likely yet, but at some point you will. I'll teach it to you. The way to tell whether these colors appear red shifted or blue shifted are there are these absorption lines, these dark lines. And when you look through the right type of glasses, so to speak, you actually see these lines interrupting the rainbow when you see a star or a galaxy, something bright. Those lines tell you something about the different elements that are in the galaxy or the star. You don't need to worry about that now other than to say the pattern of lines is the same in all three pictures, but notice the pattern in this at rest picture, the lines are where they are. The pattern in what's called the blue shift, or moving towards you picture, they're all shifted left towards the blue end of the spectrum. Whereas the red shift, they're moving away from you pattern, they're all shifted right toward the lower frequency red end of the spectrum. That is actually how the red shift and blue shift are identified when you look at a light source out in space. There are other ways this goes into it a bit more, but that's the simplest and most direct way to go about these problems. Good. And of course, don't let me forget, what do you call a person that sticks their right hand in a shark's mouth? Let him marinate. Yeah. No. Maybe. Lefty. Yeah, well, I'll give you one more. One more. What is a witch's favorite subject? That's not bad. That's not bad. Let's try one more. No. Yeah. Spelling. Yeah. Do your homework.